Hello, ladies and gentlemen. Welcome to today's session. Today we'll go for Chemistry Paper 4 2015 Major Variant 1. Let's go. Question 1. A list of substance is shown here. Then answer the question using the list of substance. State which of the substances is a basic oxide. We know it must come from group 1 or group 2. So here is group 2 oxides, calcium oxide. Next, contain carbon atoms only is graphite. Other than graphite, we also have diamond, but here don't have option of diamond. C is manufactured by fermentation, so we know it's ethanol. D is produced by decomposition of vegetation, so we know methane gas can produce by this method. E contain aluminium oxide. This is the ore of aluminium is bauxite. Cause acid rain, sulfur dioxide. It's a simple molecule with 11 atoms. Let's check this. Is C3H6. So it's 9 only. This is C3H8. So it is 11. So propane. H is produced when limestone thermally decomposes in a blast furnace. Limestone is calcium carbonate. After decomposed, will form CO2 and calcium oxide. I is a gas that is approximately 21% of clean dry air. This is oxygen. And it's a monomer of additional polymerization. So must be alkene. This is the only alkene, propene. Question 2. Atoms are made of electrons, neutrons, and protons. Complete the table. Electron have the relative charge of -1. Proton is +1. Neutron mass is 1. Proton mass is 1. Part B. Atoms of same element are known as isotopes. So we have this. Both of them have the same number of proton but different number of neutron. Complete the table to show the number of electron, neutron, and protons. So 19 proton. Atom will have the same number of electron, and then this minus this would be neutron. So 20. Next, this is again have 19 protons, but it's an ion. So this ion, they remove 1 electron. So electron is lesser by 1. So it's 18. Then the number of neutron is this minus this. It's 22. Part 3. Table 2.3 shows the relative masses and percentage abundance of 2 isotopes. Calculate the relative atomic mass in 1 decimal place. So this is easy. We just use this time this percent, this time this percent. 39.2. 3. An isotope of aluminium have a nucleon number of 27. Aluminium have relative atomic mass of 27. Relative atomic mass is the average of all the isotope mass. So the nucleon number of 27 and the relative atomic mass is exactly the same. So we can conclude that aluminium have only 1 isotope and the nucleon number is just 27. Let's see. A calcium atom have electronic configuration of 2882. Give the formula of an atom and 1 negative ion that has the same electronic configuration of calcium 2+. So calcium 2+ is this. After it become ion, it left 288. So the atom that have 288 is obviously argon. And then the question requests for the formula. So make sure you only write AR. And then they request for negative ion, so you can't tell me it is potassium plus. You must choose from here. So let's say I choose Cl. Cl that have 1 extra electron, then will form 288. Question 3. This question is about copper and compound of copper. Ask you to describe the bonding in metallic elements such as copper. So this is metallic bond. Metallic bond means that the metal will arrange in this way, and then the outer shell electron will form the electron C, while the metal will become positive ion. So the positive and negative attraction will cause it to have a strong electrostatic force, which form this metallic bond. So we just write just like that. Number 2, explain how solid copper conducts electricity. Just 1 mark question. You just tell me have freely moving electron. Part B. Copper is in alloys such as brass, State one reason why alloy are more useful than pure metals because it is harder or stronger. Name the substance that is present in brass other than copper, which is zinc. This is under alloy, you need to know. Part C. Copper sulfide crystals are made by reacting copper carbonate and dilute sulfuric acid. This is preparation of salt. When solid and aqueous, we can form soluble salt. So they say sulfuric acid have this concentration. Step 1, powdered copper carbonate added to dilute sulfuric acid. Stir, reaction happen, more copper carbonate is added until excess. Unreacted copper carbonate is separated easily by using filtration. Aqueous is heated until some of the water evaporates. Then the remaining solution allowed to cool and it will form the crystal. And the crystals are removed and dried will be the copper sulfate crystal that we want. Give two observations in step 1. Step 1, reaction between carbonate and acids. So copper carbonate is a solid plus H2SO4 is an aqueous. We know that they will form copper sulfate aqueous and then H2O and CO2. So what is the observation that we will see is the gas is formed, CO2, and also the solid is dissolved. Here's the first observation, and then CO2 released will form the bubbles or fizzing. See why the reaction stops in step 2. They add more copper carbonate until it is excess. So all H2SO4 had reacted. That's why the reaction stopped. Then part 3, name the residue in step 3. So we already removed all the copper carbonate. So the residue copper carbonate, and make sure you name it. 4, name a substance other than copper carbonate that can be added to dilute sulfuric acid to produce copper sulfate. From the acid, we already have this sulfuric. So as long as we add anything that can react with acid that has copper, then it's okay. So we can use any base, for example, copper oxides or copper hydroxide. And remember, copper is transition element, so that's why copper 2 oxide. Number 5, the solution at the end of step 4 contain the maximum amount of copper sulfate that will dissolve at the temperature. See the term used to describe this type of solution, we call them saturated. Number 6, step 1 is repeated using sulfuric acid of concentration of these instead of this, which means have higher concentration. Other conditions are all the same. The rate of reaction increase. Explain why the rate of reaction can increase. You must explain in terms of particles. So we know when concentration increase, the number of particles per unit volume is increased. So the frequency of collision increase. Seven, copper sulfate crystal have a formula of these. Take the terms used to describe the substance which is chemically combined with water, which is this 5H2O. We call this as hydrated. Question 4. This question is about nitrogen and its compound. Nitrogen contains molecule of N2, complete dot and cross diagram. So from the periodic table, we know it's group 5. It has 7 electrons, which is 2, 5. They need 3 more electrons, so they must share 3 electrons out. Another nitrogen need to share out 3 electrons also. So after they share out 3 electrons, each of them will left 2 more electrons, put here and here. And they ask for showing outer shell electron only, so you do not need to draw the 2 electrons. B. Ammonia is manufactured by reacting nitrogen and hydrogen in the Haber process. See 3 typical conditions for reaction between nitrogen and hydrogen in the Haber process. So we know it is high temperature, high pressure, and catalyst. Make sure you write them correctly. Temperature is 450 degrees Celsius. Pressure is 200 atmospheric pressure or 2000 kilopascal. Catalyst is iron. Part 2. Write the symbol equation for the chemical reaction in Haber process. We know it is N2 plus H2 become NH3. And then do balancing. Nitrogen have 2 here. Here we need to times 2. So this one done. And here already fixed have 6 hydrogen. So here also need to have 6 hydrogen times 3. then complete. C. Ammonia is converted into nitric acid in a two-step process. Step 1. Ammonia and oxygen are passed over catalyst. 1. Balance the symbol equation for this reaction. So we already know here have 4 nitrogen. So here must be 4 nitrogen also. Then here already fixed have 4 times 3, 12 hydrogen. So here confirm 6. Then here already have 4 oxygen, 6 oxygen. So total 10. So here must be 5. Then done balancing. Part 2. Give the oxidation number of nitrogen here. Hydrogen is confirmed positive 1. So nitrogen must have negative 3 to balance with the hydrogen. And oxygen is always minus 2. So nitrogen here must be plus 2. Part 3. Define oxidation in terms of oxidation number. We know when oxidation number increase, it's oxidation. Part 4. In step 2, oxygen and water react with NO to produce nitric acid as the only product. Write the symbol equation for the reaction. So we know NO will react with oxygen and water, form HNO3. Start to do balancing. Out of these 4 things, the only element is O2, so we deal it last. We can deal with nitrogen or hydrogen first. So let's say I deal with hydrogen first. Hydrogen here have 2, so here hydrogen also need to have 2. And here, because the family already fixed, so the nitrogen here must be 2. So here also need to follow, so the nitrogen need to times 2 here. Then at last, we can confirm here oxygen have 6, here oxygen have 2, here oxygen have 1. So we can confirm left-hand side already have 3 oxygen, right-hand side have 6. So this oxygen must have 3. Initially, it have 2, so we over 2 first to make it to 1, then we times 3. So this will have 3 oxygen, so left, right also have 6 oxygen. So after reach here, we cannot allow our final answer have fraction, so everything need to times 2. So the final balance situation is 4, 3, 2, 4. But the ammonia is converted into ammonium sulfate in this equation. They give you the dm cube of ammonia gas, react with excess sulfuric acid. Calculate the mass of ammonia sulfate by following the step. Step 1, calculate the number of mole of NH3. They give you the volume of 1 mole of gas. So we know we need to find back mole, which means the volume need to divide by 24. That is 15 mole. Next, calculate the number of moles of ammonium sulfate produced. We already confirmed NH3 have 15 mole. How about this? We know the relationship is 2 to 1 ratio. So here is 15, here will be half of it, 7.5. Next, calculate the mass of this that is produced. We already have the number of mole, we just times relative molecular mass. Question 5. Methanol is manufactured by the reaction between hydrogen and carbon monoxide. An equilibrium mixture is produced. State what happened to the concentration of CH3OH when reaction is at equilibrium. So we know equilibrium means that rate of forward and reverse reaction is the same, and also the concentration of the reactant and product remain constant. You must mention these two. Part B, the reaction is carried out at a pressure of 75 atmospheres and the temperature is 250. State 2 disadvantages when using pressure below 75. You need to explain in both rate of reaction and equilibrium. When the pressure is low, the rate of reaction decreases. How about the equilibrium? When the pressure reduces, they will tend to go to more number of gases. So here have 3 mole, here have 1 mole. It tends to go to higher number of particles side. So it will shift back to left, which means the yield of CH3OH will reduce. Complete table 5.1 using only words increase, decrease, or no change. Will catalyst affect the equilibrium? No. Equilibrium will only affect by pressure and temperature. So here, no change. How about effect of rate of reverse reaction? If catalyst is added, no matter the forward or revert rate, will increase. If a temperature of more than 250 is used, the yield of methanol decrease. So when increase temperature, they don't like because they already release a lot of heat. So that's why we can confirm the following reaction is exothermic. Number 4, suggest which of the element of the list is suitable catalyst. We know catalyst is always because of its transition element. If you're not sure which one is the transition element, you can refer back to the periodic table. So copper is the only transition element. Others are not transition elements. So the answer is just copper. Methanol is a member of homologous series of alcohol. State 2 characteristics of all members of a homologous series. For example, we say carboxylic acid. All carboxylic acid will have the same functional group and also same general formula. Part 2. State the molecular formula of alcohol that contain 5 carbon atoms. For alcohol, the general formula is CnH2n plus 1 OH. So when 5 carbons means C5, H11 OH, and the molecular formula you need to list down how many C, how many H, how many O. C have 5, H total have 12, and O have 1. We do not need to write 1 here. D. Carboxylic acid react with alcohol to form ester. Draw the display formula of an ester which contains 3 carbon atoms. So it's up to you whether you want to use the 2 carbon carboxylic acid and 1 carbon alcohol or reversely. So after we draw acid and alcohol, we remove the H2O in between and join them. So this would be the display formula of the ester. Of course, if you want to have 2 carbon here and 1 carbon here, it's also okay. Up to you, they give you the choice. Part 2. Butyl ethanoate is an ester. Name the alcohol and the carboxylic acid that react to produce butyl ethanoate. So the name in the front, butyl, represent the alcohol. So we know this is butanol. But start from propanol, butanol, all these will have isomer, which contain butan 1O and butan 2O. So when they say butyl, make sure you write it is butyne 1O. Then the carboxylic acid comes from here. Carboxylic acid won't affect the COH, always at the site. So that's why you just write ethanoic acid. E. An organic compound has the following composition by mass. Carbon have this, hydrogen have this, oxygen by this. Calculate the empirical formula of the component. The first thing is always find the number of mole. You just use the percentage to write as a mass divided by the relative atomic mass. We know this 12. Here is 1. Here is 16. So after we know the number of mole, we can find the simplest ratio. All of the number of mole divided by the least number of mole, which is this. So 5.41 divided by 1.35, you get is 4. This divided by 1.35, we'll get 10. This divided by 1.35 is 1. So we can confirm the empirical formula is C4, H10O. Question 6. This question is about periodic table. State the name given to group 7 element. It is halogen. B. State which group 7 element is most reactive. We know group 7, they need to receive 1 electron from outside. So when it's closer to the nucleus, the distance between nucleus and outermost electron is shortest, then the attraction forces is strongest. So this is the most reactive situation. Fluorine. If you want to write in symbol, make sure you write F2 because group 7 is always in diatomic state. C. Give the physical state and color of iodine in room temperature and pressure. It is a solid. We know when it's going down the group, it changes from gas to liquid to solid. And the color of iodine would be gray-black. D. When bromine is added to aqueous potassium iodide, a displacement occurs. Write an ionic equation for this reaction. So if you're not sure how to write ionic equation, you can just write in this way first. Everything that can form ion, you just list down. Bromine is a molecule, so no ion, but this can form potassium ion and iodide ion. Here also can form potassium ion and bromide ion. Iodine is again molecule, cannot form ion. After that, we remove everything that is on both left and right. Then the balance, we just write it. Part 2. Iodine and bromine react at high temperature to form iodine monobromide. The equation shows they give you the bond energy for all these three situations, ask you to count the enthalpy change. So first part, calculate the total energy required to break the bond in this and this. 1 mole, 1 mole. So we just use this and this, sum them together. Calculate the total amount of energy released when 2 mole of IBR are formed. So remember, it's 2 mole, so we times 2. After that, ask you to calculate the enthalpy change for this reaction, include a sign. So we just use the energy from the left-hand side, which is this, minus the energy from the right-hand side, -7. Part E, sodium is group 1. When sodium is added to water, a chemical reaction happens. Sodium react with water as an alkaline metal to form alkali, which is NaOH. Meanwhile, it will release out hydrogen gas. Give two observations when sodium is added to water, so we know gases are released. Then we can say bubbles or fizzing. And then, of course, this is a solid. Solid will dissolve. Of course, because of the density is low, that's why you can say floats on the water. 2. Thymophthalate is added to the solution when the reaction has finished. State the final color of thymophthalate. Thymophthalate is blue in alkaline and is colorless in acid. So this is a test for neutralization. So that's all for today's session. Don't forget to subscribe, like, and share my video. If you have any question, please feel free to comment here. See you in the next class. Bye-bye.